Let's move on to question number 2 very quickly. So X is an S block element. So very nice. So periodic table, and the first, second, third ionization energies are given. So when you check the ionization energy, 738, 1451 and 733. So this clearly indicates that there is a huge difference from the second one to third one. So most probably this element should belong to group 2. We'll confirm that now. The X reacts slowly with water. So when you compare with group 2, so we have beryllium, which is really reacting with water. So then we have magnesium, it reacts very slowly, and calcium, very, very slow. So it goes like that and form hydrogen and form its hydroxide. So basically, they are talking about magnesium hydroxide. X also liberate H2 on reaction with dilute acid. So magnesium plus HCl, magnesium chloride plus hydrogen. And X burns in the air with a bright white. So really confirm this is magnesium, and cation of X contributes to hardness. So basically it is magnesium bicarbonate. Okay. So identify X. So this should be magnesium. So you can write down the electronic configuration 1s2 2 p6 and 2s2. So you can write down 3s2 in fact. Then write the chemical formula of the two compounds formed when X burnt in air. So you know there is a cross relationship like magnesium and lithium. And as we know, lithium is the only one that in the first group that reacts with nitrogen in the air, and others do not react, others only react with oxygen. And in the way magnesium in group 2, it's totally different. All elements normally react with oxygen and nitrogen. So basically when it reacts with oxygen, it will form MgO, and when it reacts with nitrogen, it will form Mg3N2. Okay. Consider the given compounds of the elements group period X belongs in the boxes and whether the property increases. So solubility of sulfates, basically calcium sulfate is little bit soluble, but when you go down like strontium sulfate, barium sulfate, they are very, very, very good precipitates. So here it is decreasing, right? This is decreasing. Solubility again in the reverse way, you know, barium hydroxide is the most soluble. So solubility increases, right? Thermal stability, again, carbonates, you know, calcium, barium, strontium, when you go down, the size of the ion becomes larger, so the charge density gets lower. Based on that, the polarizability also gets smaller. So there is a big difference between the electronegativities and the when you compare the polarizability is low, mean more ionic in nature. So the stability becomes increasing. Okay, and that is what they are asked you reason for the answer 3. So what you have to do here, carbonate is similar, but the cation is different. The size of the cation is increasing. So when the size of the cation is increasing, what is going to happen for its charge density? So charge density is decreasing. Therefore, polarizability also decreasing. So hence, it forms more ionic compound, ionic nature. So the composition becomes difficult. So that is what you have to write here. Identify the element in the S block period which reacts in a similar manner. So that is what when this comes. So there is a cross relationship in the periodic table for most elements. So you know magnesium is more like lithium. So they're asking about lithium. Okay. Does not belong to the same group. So it is not belong to the same group. So this should be lithium. Identify another metal ion that contributes to the hardness. So basically magnesium, then calcium, right? Identify the compound most commonly used to remove hardness. So basically water will have two different types of hardness, the temporary hardness and the permanent hardness. Sorry. Sorry for that. And so for temporary hardness, basically the bicarbonate ions of calcium and magnesium are mostly participating. For permanent, you have chloride and sulfates of calcium and magnesium. So when you have a temporary hardness, normally we add sodium carbonate to remove them. Okay, so don't forget this one. This is a very simple thing that we normally do. X is a component of a well-known reagent used in organic chemistry. So now you know X is the magnesium. So magnesium is mostly used to make Grignard reagents, right? So you can write down here Grignard reagent. Okay. The funny part is if you find here like in a wrong banner, this is group 2 and you thought like, okay, here also there is a big gap, here also there's a big gap. All these are like very similar. And if you find the wrong answer as calcium, probably when you go to question number 8, you will automatically find, okay, I am wrong, because there are no calcium Grignards formed, only magnesium Grignards are formed. So automatically you will find a solution for them. Okay, right. So moving on. So test tubes label A to E contains the solution. So these 5 solutions are there. And when you add diluted HCl, they have given what is actually going to happen. So we will first think about that first before going to the question. Okay. So when you add Na2S to HCl, so if you remember, I have discussed this you before. When you add a dilute acid, there are anions that will give gases. So basically S2 minus, SO32 minus, S2O32 minus, CO3 minus, HCO3 minus, all those things, NO2 minus, all will give gases, right? So for an example here, there is S2 minus. So when you add HCl, it would give H2S. And here KBr, no. When you need to add the conc acid to get Br2 from KBr. Then NO2 minus would give NO2. Brown color gas is a brown. This is again rotten egg smell. So CO3 2 minus will give carbon dioxide, and S2O3 minus will give sulfur dioxide. So based on this, we can decide what are the solutions are. So the first one, let's say colorless and odorless. So what do you think? Most probably colorless and odorless when you add HCl. So you see here, all these give gases except KBr. So we will think about that. B, colorless. All these are colorless first initially, or they're telling solution appearing of the solution when you add. And remember, when Na2S2O3 add SO2 plus sulfur also forms. Okay, don't forget that one. This is also very important. Reddish brown color gas with pungent odor. Colorless gas with rodent egg. So C should be surely this one, H2S. Okay. So C should be giving H2S gas. Here they're asking the solution. Sorry for that. So C should be Na2S solution. Okay. And D, colorless with a pungent odor. So what is colorless with a pungent odor? Think about that. And E says not evolved anything. So basically KBr is E because it does not evolve anything. And A is colorless, odorless. So what can be A? So here you see here all these, it gives some sort of gases with some smell. So but here when you compare Na to CO3, it does not give any smell, odor. So where is B here? So I have to write here B separately. So B is reddish brown with pungent odor. So what is the reddish brown gas? The next one is Na2. So this is KNO2. And D, you see here D, it is turbid. Why it is turbid? Because of the formation of sulfur. So this is Na2S2O3 for D, solution D. Okay, then you need to write the balanced chemical equation for the reaction that take place in test tube A, B, C, and D. So you have to write all the reactions, right? For A, what is A here now? Sodium carbonate. So you need to write sodium carbonate plus HCl, what is happening? Okay, so this could form NaCl. So NaCl and water plus carbon dioxide. So this is one. And B is what is B now? KNO2. So again you can write KNO2 plus HCl. It would form KCl. So it would form KCl. So HNO2 will be remain here. So basically HNO2 is going to break down as NO2 plus water. So that is what normally happens. NO2 plus water. Okay, but don't forget, sometime HNO2 would form NO gas as well. So if you write KCl NO2 plus NO plus water, it is also correct. Okay. Then C, you have this Na2S again plus HCl. So this would give NaCl and H2S gas. That is very straightforward again. And finally, the last one is sodium thiosulfate. Na2S2O3 react with HCl would give NaCl, SO2, sulfur, and water. Okay, that is the reaction. Write a chemical test to identify each of the gases involved in A, C, and D. Observations are also required. So what is A here? Carbon dioxide. So you can tell, you can send lime water, so calcium hydroxide. You will see a milky color formation for A. For C is, it is sorry, C is H2S. So how can you identify H2S easily? You have to just test a filter paper that is moist with basically lead acetate. So when you have lead acetate, when you supply H2S, it will form PBS, the black color one. So that is one identification. There are many, but that is the basic one. Or either you can write down cadmium acetate as well. So or you can acidify KMNO4, you can tell the color change or like that. D, it is SO2 again. So SO2 also is very similar. You can send that through the potassium dichromate solution or KMNO4 solution. So the purple becomes colorless or the orange color becomes green. So those two can be written here. Okay. So this is a very simple question. Second one.